Welcome in Magav Engineering. As it usually is, I started to do some smaller projects, maybe not as significant. Well, you may get something out of it. And I decided just to turn on the camera because, I'm like started, maybe it's something interesting or not. Well, this is a drum out of a tumble dryer. And this is the spider, the back of it. And as you can see, it got broken. So it was installed in here on those stainless steel rivets. So first of all, I had to remove it out of the drum. And well, maybe something worth mentioning. I found this tumble dryer in front of a repair shop. They just put it outside because probably they just didn't take that job on them. I understand. You cannot buy those. So instead of somebody else, basically the garbage guy or the junk guys picking it up for scrap metal, first of all, I looked, can I fix it? So maybe not. This part is unobtainable. You would have to have another one like that to use the drum, and too much problem, I guess, for most of us. This is the other part, the bearing. This you can buy actually. This is the plastic bearing that sits on it. At first, I will try to reproduce exactly this thing over here. Well, definitely not exactly, something like that. And if it works, if I will find something, if I will find out that this could actually work, then I'm gonna order the original parts. And until then, I'm gonna basically play with myself with here. Yeah, you make something out of it. What I said. Okay, so I have this piece of aluminum. This is my own aluminum. I make it out of scrap metal. There is a junk bin here with aluminum. All that stuff is going to get melted into something like this, for example. Very bad quality, very poor quality, but who cares? Who cares? It's for free, yeah. So right now I'm in the process of making the because one side is flat. I saw it on this here bandsaw, but the other part, the other side is ugly. There is even some marks after I tried to make a pulley for my sewing machine, but it failed. The blade got broken, so I gave up making the aluminum one. But yeah, we have another project to fix. Yeah. So I'm making this flat. I'm using 8mm HSS end mill on a drill press. And basically, most of this most of this process is going to be performed exactly with this very tool. So, I will try to cut off most of the ah and ox from this video, but I would rather shot it in as short pieces as possible. Okay, I know what you are going to think about that. Yeah, but these are my hands. This is my machine. and I can screw it up as much as I'm pleased. So the idea is, right now I have this flat spot in here. I don't think I need the entire surface of it to be flat, because most of the job that I'm going to do is going to be on the other side of this plate. The rest of this process, I mean on this side, I'm going to do after I will be finished with the other side. For the simple reason, it's much easier to do the stuff on the top, since it's only basically about removing some of the material. I'm not going to reproduce this part exactly. I'm just going to focus on its main functions, which is first of all, those legs, they have to be flush and flat, you know, so that's why the other side is flat, and I'm going to reference towards that one. The other thing is this piece of metal, the grounding connection to the shaft of the drum. It has to be retained in this or other way. Of course, I can do it in completely different fashion. It doesn't have to be exactly the same way. So probably I'm just gonna skip this part over here and, you know, maybe add a tensioning, one extra tensioning element that would be screwed into this or something like that, or just simply bend this one, or completely use a different type of grounding. It's just important to have this connected. And the other quite important thing is this tab over here, because there is a plastic washer that I don't have at this point. It comes with the original set that sits under the this washer. This is screwed, and there is a plastic one that is sliding, you know, preventing you know, the metal to metal contact. And this tab has to go in between those two. So probably again, I'm not going to think too much about that at this stage. I'm just gonna machine it so I would have the proper surface for the tab, and then probably just cut into the existing metal that would be all around, and not playing with some small dicky things like that. You know, I don't have to engineer that towards using the least possible material ever. You know, I'm going to make it so it would probably be just as strong, even though this aluminum is a piece of crap. And yeah, let's continue. Okay, what I done now is I outlined the approximate direction of what I want to get. The red holes correspond to the holes in the drum. The center should be more or less center. The proper centering of that I'm going to do already all at the drum. And yeah, maybe that wouldn't be so stupid to do it right now. Well, screw that. Or maybe, yeah, I'm going to do it exactly now. Okay, so I pre-drilled this, you know, pointed out where are the holes, and it seems that my previous approximation was quite correct. What I did, I changed the tool for the 60mm drill. Probably the inner diameter of this is bigger. I mean, I measured with calipers, and it's like, you know, 20mm. So I think if I start with 16, when I will get the original bearings, then I will change it and bore it out to a larger diameter. I also did this thing over here. I center it more or less. I don't know if you can see. Yeah, on this table. This table is not perfectly on center, so you know, again, don't count on super accuracy on a drill press. It's not going to happen. All right. Okay, now plan is to go as deep as necessary to get to this surface over here and you know, make this flat over here to on which the washer is going to rest, the plastic one I mentioned before. And it's about 10 millimeters off this surface. So this is exactly what I did here. I got 10 millimeters deep into the material. And right now I'm going to lock the side and I'm going to go on the axis of the center. And as I mentioned, the middle is not completely flat, so you know it's not going to be perfect. Yeah. Right now it's about 20 millimeters diameter over here on the top. So now I need to leave this piece for the tab of this washer to rest in, and I will basically go in the semicircles back and forth around it until I get over here, and then I'm gonna jump around it because I think it's better if there is a little bit more empty space over here. You know, the less probable that there will be gunk accumulating in here, the better, I think. I guess, I don't know. We will see. Okay, this is what I have so far. Yeah, so the grounding tab goes right in here, and on the other side, you know, I'm going to either drill a few holes and just push it underneath the lip, or otherwise I'm gonna basically bolt it down on the other side as well, or tighten it with a wire. It doesn't matter until it's stainless. And yeah, time to flip it around because I'm not going to machine anything around over here. This is going to be as flat as it is, and I'm just gonna cut off the edges with the, you know, with the bandsaw, and that's it. Okay, and right now I cut off all the unnecessary junk around it, and the next important dimension is definitely the depth of the bushing itself. So it's about 60 millimeters right now. Here, between here and the flat is about 20, so I'm taking off 4 millimeters. And it will proceed exactly like I did before with the flat on the other side. So a little tighter. Well, I guess my material got loose. So this is what I made so far. On the other hand, on the other side we have this. So this is the most important part. This is going to face the other part of the bearing, plastic bearing. Of course, I need to deburr everything because it's ugly. Probably this hole will need to be enlarged. And what I'm going also to do is to take a saw and basically cut off all these flats. So the most, let's say, extended part will be just the face of this bearing, nothing more. And maybe at the end I'm gonna also give it a little polish with sandpaper, so it will not grab too much of fluff inside the tumbler dryer. And this is the end ready part. Instead of ordering the plastic bushing that I'm kind of well, the person that is taking this dryer is not really sure if they are going to use it or not, so I just decided not to spend even a 10 cents on that, and I just made one bushing out of brass, which possibly will be even better in this application. Who knows? It also doesn't require the extra grounding. Yeah, this is the best I could achieve without reamers, without proper end mills and so on. So there is zero play in this. It's very, very tight. I basically sized the hole inside and then proceed with a sandpaper. First 240 and then 600 grit, and yeah, as I said, there is no play, and the height is precisely as needed. Now I also added a little bit of a black graphite lube, which should be very good for this application, because since it's a copper and steel, they agree very well with graphite and low RPM. I'm not really sure if it's even required, but I think it's better if there is something. This is a thread locker. Okay, all right. The bushing is a little bit longer than the hole, so sorry, the pin inside is a little bit longer than the bushing, so it makes no resistance over here, and there is no play towards this way as well, and this spins really nicely here. I think it's gonna last at least very long, and if it will get broken, probably it will start to eat the aluminium first, and it's not gonna go really bad very soon, so we're gonna hear some indications of stuff going bad. Now I do not have any stainless steel rivets, so I basically tapped and drilled and tapped this spider, and I'm gonna use this stainless steel hex bolts on the inside. I just need to drill out this a little bit bigger, and that's it. More videos coming soon.